Hey, what is up guys? Welcome to another video. In this video I'll be talking about how to factorize quadratics. Before we start, there's some key skills you need to have. So you need to be good at factorizing, so factorizing numbers. So if you see a number like 63, you need to be able to quickly see that what factors make 63. So you can see that 63 is 1 times 63, or 3 times 21. 4 and 5 don't go, 6 doesn't go, so 7 times 9 makes 63, and 8 doesn't go. So you can see, quickly break numbers into factors. The other key skill you need to be able to use is multiplying negative numbers. So negative times a positive makes a negative number, and a negative times a negative makes a positive. And also, I'm assuming if you're looking at factorizing quadratics, then you've already factorized binomial expressions, or expressions with two terms, such as 2x squared plus 4x, and you would know how to factorize this. You would see that there's a common factor of 2x here. If you take that out, you're left with x plus 2 in the brackets. So you're able to factorize binomial expressions, or expressions with two terms in them. So if you're good with all of that, then you're ready to go into factorizing quadratics. If you're not sure about any of this, you can watch a video I've done on factorizing algebraic expressions. That's looking at expressions such as this with two terms. It's a little bit less complicated than factorizing quadratics. So that are the key skills you need, and if you're good with all of that, then you'll be fine with factorizing quadratics. So what is a quadratic equation, or a quadratic expression? Well, quadratic comes from the Latin word quadratus, which means squared. So a quadratic is anything with a squared term in it. So x squared is a very simple quadratic. And if I add an equals sign, then it becomes a quadratic equation. Now a quadratic can have three terms in it. It can have an x squared, and then an x term, and then an integer term. So this is an example of a quadratic expression with three terms in it. So that's what a quadratic is. And why do we care about quadratics? Well, they turn up in all sorts of areas. They predict the path of a ball thrown in the air. So if you throw a ball in the air, it makes this kind of a path, up and down, nice curve, and this is actually the graph of a quadratic equation. They show up in business when you're graphing how to make a profit on something. Generally the graph looks like a parabola like this, and you can use a quadratic to predict how many items you need to make a profit. They show up in manufacturing, and building, and engineering, and lots of different areas. And actually we've been studying quadratics for thousands of years, dating back to the Babylonians. And here is an example of a problem that they might have had to solve. So a farmer knows the amount of land he needs. He knows he needs 55 units squared worth of land. And he knows that one side of his land needs to be 6 units longer than the other. So he knows he needs 55 units of area, and he knows that this long side needs to be 6 units longer than the short side. And he wants to know how long this short side is. So the way that we might represent this now, we might call this short side x, and this long side x plus 6. And then what we can go ahead and do is say that x, or the short side times the long side, x times x plus 6 equals 55. So x squared equals x squared plus 6x equals 55, and you could solve that. And then you could find the length of the short side. Babylonians didn't have algebra, so they actually used what we now call completing the square, where they cut the rectangle at a certain point, and then they create a square out of it. I won't go into that now, but this is an example of a problem that they were solving thousands of years ago. But that's a very simple example of a type of problem that will produce a quadratic. So, as I said, they show up in all sorts of different areas of life, and it's important to have an understanding of quadratics. Now, we're talking about factorizing quadratics. So if you're given a quadratic such as this one, x squared plus 5x plus 6, what you can do is to break that into factors, and what you end up with is two brackets. And in the first bracket there'll be x plus something, and in the next bracket there'll be x plus something else. Let's just see why that happens. So the key here is to split the middle term into two parts, and what you end up with is two binomial expressions, or two expressions with two terms in them. So let me show you what I mean by that. So we leave the x squared as it is, and then we'll break this 5x into two different parts. And here I'm going to break it into 2x plus 3x plus 6. So you can see here all I've done is break that 5x into 2x plus 3x. That's the same thing as 5x. And now what I can go ahead and do is to factorize this first part of the expression and the second part. So if I factorize this first part, the common factor here is x. So I take the x out and I'm left with x plus 2 in brackets. And then I'll factorize this second part of the expression. So the common factor here is 3, so I take 3 out and left with x plus 2 in brackets. And the important part, the key step here is to recognize that we have the same terms in the brackets here. If they weren't the same, we'd have to go back to this second step and change these parts of 5x and break them into something else. But because we've got these same terms in the brackets, what we can do is to actually factorize that bracket out of each term. What do I mean by that? Well, let's substitute something in for those brackets. Let's say this, instead of writing x plus 2 in brackets, we'll say that those brackets are represented by a letter, let's say capital A. So here we've got x capital A plus 3 capital A. So how would I factorize this? Well, the only common factor here is capital A, so I'd say this is A bracket x plus 3. But remember, I let those brackets equal the capital A, so this is just going to be, if I factorize those brackets out, this is going to be x plus 2 bracket x plus 3. So you can see here I've worked from this quadratic and I've factorized it down to two brackets. And eventually what you're going to get to is, once you've got the hang of this method, you'll be able to skip all of these steps in here and just jump straight to the double brackets. And let's talk about how we can do that. So that's kind of, if you like, the long way, or the more complete way to do it. Let's look at another example. So if we have something like x squared minus 8x plus 15, what I'm going to do here is to aim to break this into two brackets straight away. So the first terms, if there's no coefficient of x, they're just going to be x and x. So I write them in first, and then what goes in at the end of the brackets is they are going to be factors of 15, that sum to negative 8. Also include the signs in here. So the integers in these brackets are factors of 15 that sum to 8. So let's have a look at the factors of 15. So 15 could be 1 times 15 or 3 times 5. And they need to sum to minus 8. So 1 and 15, well, that can't possibly make 8. So I cross those out. So it must be 3 and 5. and they need to make -8, so it must be -3 minus 5, that's going to be -8, and -3 times -5, that makes +15. So I can use those -3 and -5 as my terms in these brackets, and I'm done. So that's, if you like, a shortcut to skip those steps in there. You can always do it this way if you don't feel confident with this method. But there you go, I factorized x squared minus 8x plus 15. Now let's have a look at an example with a coefficient of the x squared term. 3x squared plus 35x plus 50. Again, you could do this the long way. You could split this middle term into two parts and then factorize both parts of that expression and then break it into two brackets. Again, I'm going to take a shortcut and look for two factors of 50 that sum to 35. So the factors of 50 are 1 times 50, 2 times 25, and 5 times 10. I think that's all the factors of 50. 7, 8, 9 don't go. Okay, so I need two of these factors to make 35. But also remember that because of that coefficient of x, one of them has to be multiplied by 3. So the only two factors of 3 are 3 and 1. So I can write these factors in 3x and x. They multiply to make 3x squared. And one of these factors needs to be multiplied by 3, because when we expand these brackets out again, one of those factors will be multiplied by 3, and they need to sum to 35. So 50 times 3, that's 150, and 3 times 1, that's 3, and neither of those is going to make 35. So I can cross that one out. 2 and 25, 2 times 3 is 6, and 25 times 3 is 75. That's not going to work. So I'm left with 5 and 10. And if I multiply 10 by 3, that's going to be 30, and add 5, and that's going to make 35. So I can use 5 and 10 here. Now the 10, because I've multiplied the 10 by 3, that goes at the end of these brackets, and I put the 5 in here. Okay, so you can see here I'm using factoring and basic arithmetic skills to kind of take a shortcut and skip these steps here. In an exam, these might be my rough notes on a spare piece of paper, but all I'd show is this step here. I wouldn't show anything else. Okay, let's look at one more example, slightly more complicated. So 28e squared minus 85e plus 63. Okay, so here we've got a coefficient of the squared term, which also has more than two sets of factors. So what we want to do here, again, we're going to break this into two brackets, and we're going to think of the factors of 28 and the factors of 63. So the factors of 28, 1 times 28, 2 times 14, 3 doesn't go, 4 times 7, 5 and 6 don't go. So that's all the factors of 28. 63 is 1 times 63, 3 times 21, 4 and 5 don't go, 6 doesn't go, 7 times 9 and 8 doesn't go. So that's all the factors of 63. Now I need to match up some of these factors, and they need to sum to 85. And this is where we use trial and error. Factorizing quadratics in my mind is mostly about trial and error. There's no real shortcut to bypass this step unless you do it this way, which is fine. Maybe you would prefer to do it this way, as it's kind of more methodical. And also remember that some quadratics can't be factorized, and in that case we need to use the quadratic formula. But usually exams are pretty nice in that they'll tell you whether a quadratic can be factorized or not, or they'll tell you to use the formula. If you can't factorize a quadratic, just stick it into the formula. It's no big deal, you'll still get the same answers. But anyway, let's continue with this example. I need to multiply some of these factors together, and they need to sum to 85. So what I'm going to end up with is two products of these factors. And one way to do this is just draw a little cross and draw the factors of 28 over here. So I'm going to pick 4 and 7 first, and then pick some factors of 63 that you can try, and I'm going to try 7 and 9. So put the factors of 63 on this side. So the product of 7 and 7 is 49. So on this side I get 49. Product of 4 and 9 is 36. Okay, and those numbers are what need to sum to 85. So 49 and 36, if I add those, they make 85, but we need negative 85, so they both need to be negative. So if I've got negative 36 minus 49, that's going to be minus 85. So I've got my factors now, 4 and 7 and 7 and 9. And all I need to do is to make sure that they match up in the brackets. So the 4 is on this cross, the 4 is matched with the 9. So they go on the outside. And the 7s are matched up, so they go on the inside. And they're both negatives, so both terms in here will be negative 7e. Okay. And if you want to double check, you can expand these back out using FOIL. I've done a video on expanding brackets, and I went through 3 methods of expanding double brackets. One of them is FOIL, so if you want to check your answer, expand them back out just to double check. So 4e times 7e, that's 28e squared. And then you do the outer terms, which is minus 36e, the inner terms minus 49e, and the last terms, that's plus 63. And that's going to be 28e squared minus 85e plus 63. You can see here I get what I started with, so this factorization must be correct. Now let's talk about quadratic equations. So I'll use the same example I started with, x squared plus 5x plus 6. And then usually if it's an equation, it will be equal to 0. Of course, you could have it in a different form. You could have it in a form such as x squared equals minus 5x minus 6. And what you have to do there is to rearrange it so that you add both terms to the left-hand side and you end up with this. So once you've rearranged the quadratic to get it in this form where it all equals 0, then you start to factorize. And then all it is what we've just talked about, which is factorizing the quadratic. So we've already done this one. It was x plus 2 and x plus 3 equals 0. And now what you can say is that if you've got two numbers multiplying together to equal 0, let's say I had 10 times something equals 0, well, what would that number be? It has to be 0. There's no other possibility. And also if I had something times, I don't know, 5 million, for example, could be any number equals 0. What would this number be? It has to be 0. So we use that fact to find the solutions to this equation. So either x plus 2 equals 0 or x plus 3 equals 0. One of them has to equal 0 because we're multiplying them together to get 0. And then we can say that x equals minus 2 or x equals minus 3. So that's just the extra step involved if you're given a quadratic equation. But I really think that the main step here is to be able to factorize quadratics and also to get them in the form where they equal 0. Once you're good at that, this step is not so difficult really, just rearranging an equation. Okay, so factorizing quadratics, that's everything that I really wanted to say about that. There's the longer way involving splitting the middle term up and factorizing the first part of the expression and the second part of the expression and then combining them. And then there's this, I guess, shortcut where you're looking for factors of the last number that sum to the middle number. And then if you have a coefficient of the squared term, you also need to find factors of that number and match them up with the factors of the last number. And then it's also about trial and error. So once you understand that, it's just about practice, practice, practice. So I've included a bunch of practice problems in the description of this video. There's two sets of practice problems. One is 30 questions, a quick 30-minute revision session. I've also included the answers to that, and then the other one is, it's called increasingly difficult problems. So it starts off fairly easy and then it gets harder and harder as you go down the page. But if you want to have a go at those, I'll put them in the description. I hope you found this video useful. Leave a like if you did. If I went over anything too quickly or that there are some steps you're not quite understanding, let me know. If you have anything to add, let me know in the comments. And if you want to see more content, subscribe. Other than that, I'll see you in the next video. Bye for now.